Okay, in this example, we're going to take a look at the limit numerically, and just one more time, the informal definition of limit. So I've already talked to you a little bit about what this means, and so hopefully by now that's becoming a little more clear what the definition means. And then in the previous examples, we didn't really have to worry too much about this first part here, so I didn't really mention it too much. But now in this example, we're going to see what happens when we take the limit of a function at a number that's not in the domain of the function. So this first part here sort of comes into play. And the function that we're going to look at is the same one that we looked at in example 2. So it's the same one, except in example 1 we were looking at the limit as x goes to 0. Now we're looking at the limit as x goes to 2. And if you try to plug a 2 into this function, on the bottom you're going to get 2 squared minus 4, right, which is 0. And so that's division by 0. So this function is undefined at 2. So 2 is not even in the domain. It's also undefined at negative 2, right, because if I plug a negative 2 into that function, it will cause the same issue. But that's it. Every other number is okay to plug in here. You just can't plug in 2 or negative 2 because you'll get a division by 0 here. And so the domain of this function is all real numbers except for 2 and minus 2, so it does satisfy that condition. It's defined on some open interval around 2, but not exactly at 2. So I'm going to use the Desmos.com just to take the limit again. And so here's the function that we had, right? And so if you take and change this and try to plug in a 2, you'll see what Desmos will tell you. Hey, it's undefined. You can't do that. You can't plug in a 2 here because you wind up with a division by 0, and that's a mathematically meaningless expression. So now this example is a little bit more interesting than the other examples that we have already taken a look at, just simply for the fact that we can't just plug in the number here to get the answer for the limit. So it's gonna be something else besides what we've been doing here lately. So let's take a look at the table for this one. And here we're going to be approaching 2 from the left, right? So I started at 1.9 and then moved a little closer to 2, right, on each one of those. And you can see the corresponding y values that I get right here, and you can see a definite pattern here. It looks like each time I am getting a little bit closer to 7.75, so 3/4. It looks like I'm getting closer and closer to that number. Okay, so that's what's going on when we're a little bit less than 2. In other words, on the left of 2 on the number line. Here, I am going to go to 2 from the right side. In other words, I'm going to use numbers that are a little bit bigger than 2. So when I do that and plug those in, you can see the corresponding output values or y values get closer and closer each time to 0.75 again. So definitely you can see the same pattern happening from both sides. So this is really the first example that we've had where you couldn't get the limit just by plugging in the number here. So this is telling us, what it's telling us is what happens to x values the closer and closer you get to 2, right? The closer you plug in, the closer you get to x, or to 2, all right? And when you plug that number in, you're going to get an output value that's pretty close to 3/4. But, right, this has nothing to do with what's going on actually at 2 right here. The limit doesn't really care what happens at 2 or not, because at 2, this function is undefined. So this is a little bit more information that we had about what's going on at 2 right here. So again, the limit doesn't care what is going on exactly at 2. The limit, the number that you get, describes what's happening to the y values the closer and closer you get to 2, but are not equal to 2. And so in this case, what we wind up with is that those values are equal to 7.5 in the limit here. So the limit as x goes to 2 of this function is 0.75.